everyone. I made this video for us for our upcoming test on acid-base balances. And so what I wanted to do is kind of give you some helpful hints that help me kind of understand it a little bit better. The first thing I want to talk to you about is the board position. So as we talk about acids and bases, as you can see, 7.35 to 7.45, this is going to be our neutral, our good parameter. Anything to the right is going to be your acid alkalosis, and anything to the left is your acidosis. But I'll point that out as we go through here. So the main purpose of this is understanding Rome. So as you are aware, Rome is respiration equals opposite, and then metabolic is equal. So as we go through this, our parameters, as I talked about pH, was 7.35 and 7.45. So within that, we're functioning at homeostasis, so everything's good. Other parameters that we need to know is your CO2. You're going to have 35 to 45 millimeters of mercury, and then for your bicarb, you're going to have 22 to 26 milliequivalents per liter. So those are the base parameters that we need to know for some of these tests coming up. And then from there, what I'm going to talk to you about is the boxes. As we go through these diagrams, the pictures that I have, focus on the squares, because the squares will make it easier, and then anything outside the squares in terms of this, we'll get to it later when I give you more on compensation and stuff like that. Okay? So what we're going to do is go over a couple things, a couple organs that are going to help you with your acid-base imbalances. Now I'm on the left side of the board, and I'm on the lung side. That's what we're going to talk about first, is your lungs. In terms of your CO2, if you have an increase in CO2, your lungs are going to help you by having faster and deeper breathing. This is also called hyperventilation. This is all going to be occurring by your chemobaroreceptors. Right side, now we're on the alkalosis side, right? So for your lungs, we're going to have a decrease in CO2. And with a decrease in CO2, you're going to have slower and shallow breathing. This is going to be your hypoventilation. And then what we're going to do is, now once you look at the lungs, now you're going to look at the kidneys and how they function in maintaining acid-base reactions, balances. So for the kidneys, the biggest thing is they're going to retain hydrogen by excreting less of it. So this is going to be in terms of alkalosis, okay? And then what we're going to do is walk over to the left side in your acidosis side and see what the kidneys are going to be doing. So now I'm on the left side, and for your kidneys, you can see here that because it's acidosis, you're going to have the bicarb is going to be retained, and you're going to have more hydrogen being excreted through ammonium, which is going to be your NH4+. So those are the basic functions of how your body is going to try to compensate for your acid-base balances. It's either going to be through your CO2, through breathing, or through your hydrogen excretion in your kidneys. Okay? Okay, so what we're going to talk about now is the method of using Rome. So the first thing we're going to talk about is respiration is going to be opposite. So for respiration is opposite, right here we have respiratory acidosis. As you're aware, I'm on the left side of the board, and we're going to be having a pH that's less than 7.35. So on respiratory acidosis, what you want to look at is your pH. You know that your pH is down, then you're going to look at your CO2. Your CO2 is up on those values, and when I say CO2 is up in those values, you're going to take that value, that parameter that you had to learn, the 35 to 45 millimeters of mercury, and you're going to apply it. So at this point, it's going to be showing higher than 45 right here. Because it's showing higher than 45, we're going to look at both of these, the pH and the CO2. They're opposite. Rome, respiration equals opposite. So your pH and your CO2 are opposite. Now I put a question mark on your bicarbonate because that's going to determine compensation for this stage. Now the next one that I want to show you is the same thing, respiratory alkalosis on the other side of the board. So I'm going to walk over. Now I'm on the right side, and I'm in the alkalosis side, so I am higher than 7.45. And we're going to talk about respiration. Remember, respiration deals with your lungs. It's all about your CO2 and your breathing. So for respiration alkalosis, respiratory alkalosis, you're going to have a higher pH, which makes sense. I'm on the right side of the board. Then you're going to look at your CO2. Your CO2 determines your acidity, right? So we're going to have a decrease in CO2. And then, of course, if you look at the Rhone, respiration is opposite, or respiratory is opposite, then you're going to have opposite arrows, okay? And that's it for that. I kind of drew that thing for you. Your bicarb is a question mark because your bicarb is going to depend, the values depend on your compensatory mechanism, which is going to be 22 to 26. Any of those values less or within or outside of that on the high side. All right, so now what we're going to talk about is, since I'm already here, is metabolic acidosis. On metabolic acidosis, you know that the same thing, pH is down, so you're going to have a decrease in pH. I'm sorry, this is wrong. I made a mistake, so if you watch the previous sections, you're going to see that these don't match. I realized that I had it backwards, so I went ahead and corrected it. So for your pH, you're going to see that on metabolic alkalosis, you're going to have an increase in pH. You're also going to have an increase in your bicarb because its metabolic is equal, and you know these two arrows are going to go up. They're going the same direction. And again, your CO2, it's going to be a question mark because that's primarily for your compensation. All right. And lastly is your metabolic acidosis. So on your metabolic acidosis, I'm on the left side of the dry erase board, and our pH, of course, is going to be less than 7.35, and our bicarb is going to be lower, right, because we're more acidic. Higher bicarbs means we're more alkalotic, and so both of them are going down. So again, M metabolic is equal. So you're going to have two arrows going down, and your CO2, again, it's a question mark because it's going to depend on if it's doing any compensatory or compensation for the acidity. Now that you kind of see these values, you can kind of start seeing with problems that they give you. One problem is that we wrote is for number one, if your pH is 7.21, your PaCO2 is 60 millimeters of mercury, and your HCO3 is equal to 24 milliequivalents per liter. Can you tell me what that's going to be? And if you wrote respiratory acidosis, you are correct. All right. For compensation, if you look at the parameters, all you're going to have to really do is find out first what state you're in, respiratory or metabolic acidosis or alkalosis. And then you're going to look at your values of how is it compensating. So for this one, for respiratory acidosis, what you want to look at is your bicarbonate. So we know that your pH is going down, your CO2 is up, and we don't know what bicarb is doing. But based on the other arrows over here, if you can see, on these parameters, what I did is I wrote arrows, drew some arrows, and that's going to tell you what those parameters are trying to do as in terms of compensation. So if you see 35 to 45, if you see something higher than 45, let's say 50, it's trying to become more acidic. Versus if you're down here and if it's basic, or it's more acidic, If it's less than 35, let's say 20, it's trying to make it more basic. So it's a little bit opposite of what the parameters are showing you for the pH. The one that does follow with pH is your bicarb. For your bicarb, your normal levels are 22 to 26. And so if it goes to the right, if you have higher than 26, it's going to be more basic. And lower than 22 is going to be more acidic. So when it is less than 22, this is trying to make it, it's more acidic, so it's only helping it. So compensation would be the other way. You're compensating your HCO3 through your kidneys by increasing your bicarbonate higher than 26, which would make it more basic. And then that rule would apply to the other scenarios. It's usually going to be opposite of what the pH is doing because you're compensating. All right, and I hope this video helps. I made some mistakes on there, but I'm learning from this. Make some comments if you want. Hopefully I didn't mess it up too much. All right.